We're solving problem 24 from the 2020 F equals MA exam A. A mass M is connected to one end of a zero-length spring with spring constant K. The other end of the spring is connected to a frictionless bearing mounted along a horizontal pole so that the mass can swing in a vertical circle of radius r around the pole. The setup is shown in the figure below. What is the vertical distance h between the center of the circular orbit and the axis of the pole? Assume that both the diameter of the pole and the rest leg of the spring are negligible compared to r. So here we have this spring. R denotes the length, and this is obviously the middle of the pole. And where x comma y is just a random point that swings. So we can see that the force F at any given point without the influence of gravity is negative kx, negative ky. And this is without gravity if you're in like space or something. But if you are under the influence of gravity, then the x component doesn't change, but the y component has to be subtracted by mg, mass times gravity. So therefore it does shift down. We want to shift this point so much so that we can call a new variable y prime to be y plus mg over k, where this perfectly plugs into this y so that our f under the influence of gravity becomes negative kx comma negative ky prime. This shows that hence it spins in a circle when y prime is equal to this, so therefore our tangent height h is simply mg over k. That's our answer, how much it's shifted down.